is one solution. It covers properties of functions, sketching of a function, and trigonometric, logarithmic, and exponential functions. Look at the first question. The first question states, if the adjacent and the opposite sides of angle A of a triangle are equal, then pi over 2 minus A equals to, we have to figure out this. Now, the angle A has the opposite and adjacent equal. If the opposite and adjacent are equal, and we're looking for sine and cosine in a triangle, that means one of the angles must be 90 degrees. If that angle is 90 degrees, then the hypo will not be one of the two sides that are equal, because it cannot equal to one side, because the hypo equals to the square root of the squares of the other two sides. So in that case, these two sides must not be, any of them must not be the hypo. That means for the angle A, one of them will be the opposite and the other one will be the adjacent. Having stated so, we know that the third angle is 90 degrees, and since the two sides of this angle A are equal, then the angles should also be equal. If the angles are equal, then the angles each must be equal to pi over 4. Let's go ahead and look at the solution to the problem. Here is our logic. Since the adjacent and the opposite for angle A are equal, it follows that A equals to pi over 4, and from that we can just figure out pi over 2 minus A, which we just said it's going to be equal to pi over 4. So the answer will be equal to pi over 4. We have to plug in it right there. Let's take a look at the next question. Next question states that the point P, which has an x-coordinate -4 and a y-coordinate equal to 4, is the dimension of an angle in a triangle. Then the cosine of the angle equals. One more time. This point is at one of the corners of a triangle, and the point has -3 as it is x-coordinate and +4 as it is y-coordinate. If that is the case, then we want to look at cosine of that angle, and the answer is one of these four options. So let's take a look at the solution. Since the dimensions of P are -3 and +4, the opposite and adjacent are -3 and +4 respectively. It therefore follows that the cosine of the angle is 4 over 5, which is the adjacent divided by the hypo. That is the case, then the answer will be 4 over 5. Let's justify this by looking at a figure. Here is a circle. This is the x-axis, this is the y-axis, this is the point P. Since anything to the right of the y-axis is positive for x, anything to the left of y-axis is negative, so this point is -3. This point has x equal to -3, y equal to 0. This point has x equal to -3 and y equal to 4. We want the cosine of this angle, so no question that the opposite is -3 and the adjacent is +4. Since the adjacent is +4 and the opposite is -3, the hypo must be equal to 5. So the cosine of this angle is the adjacent, which is 4, divided by the hypo, which is 5. And that's the answer, 4 over 5, which is right here. Next question. The next question is as follows. Ln of 8 divided by ln of 2 equals to, and we have 4 choices. Let's take a look at the solution. Ln 8 over ln 2 equals 2. We could change 8 to 2 to the power 3. Since we can say ln 2 to the power 3, then we can take the 3 to the left of the ln. It will be 3 ln 2. One more time, ln 8 equal to 3 ln 2. And we are dividing by ln 2, so this ratio we can cancel ln 2, and that's going to give us the answer as 3. So the correct answer is D. So D is going to go right there, which is the number 3. Let's take a look at the next question. The next question is as follows. Let sin A be equal to 0.8. Then sin 2A equals 2, and we have 4 options to pick from. Let's take a look at the solution. Since sin A equals to 0.8 implies the opposite to A is 4 and the hypo is 5. It follows that the adjacent is 3. Thus, cosine A equals to 3 over 5. Therefore, sin 2A equals to 2 sin A multiplied by cosine A equals to 2. We know that sin A is 4 over 5 and cosine A is 3 over 5, as we concluded right there. So if we do the math, that's going to give us 24 divided by 25, which is option D, which is going to go right there. The next question is as follows. For how many cases the function y equal to a to the power x decreases? Let's take a look at the solution. When a is greater than 0 and less than 1, we're going to get a greater than 0 and less than 1. So whenever we raise it to a point, and that point is an integer that is positive, because we're looking at the increasing of x and its impact on a to the power x. If x increases and the base is a fraction, then the function will decrease. The second case where the function decreases is when a is negative value. That means the base is negative value and x is an odd number. That's the second case, and you can go ahead and verify that. So we have 2 cases and the answer is B. This is the answer 2. Let's look at the next question. The next question is as follows. If 16 to the power c equals to 8, then the value of c is equal to, and we have 4 options. Let's take a look at the solution. 16 to the power c equals to 2 to the power 4 times c, and 8 is equal to 2 to the power 3. Since the base is the same, then the exponents must be equal. That means 4c must be equal to 3. It follows that 4c equal to 3 implies c equal to 3 over 4, which is equal to 0.75. So the answer is going to be over here 0.75. The next question is as follows. For any given function f of x, the horizontal line test verifies if f of x is. Horizontal line test is a test that detects if the horizontal line intersects a function in exactly 1 point. So if that is the case, then we are looking for a function f of x is it going to be even odd, neither even nor odd, or not even. One of these is the answer. Let's take a look at the solution. Solution is going to be as follows. For even functions, the condition is f of minus x must be equal to f of x. What does this mean? This means that for every unique value of y, there are two values of x. Since for every unique value of y, there are two values of x, that means the horizontal line will intercept the function in two different points, not one. So it cannot be passing, or it cannot pass the horizontal line test if it is even. Thus, it fails the horizontal line test, which requires f of x to be unique for different values of x. What does that mean? That means for every x, there is a unique value of y. And for every y, there is a unique value of x, as long as x is in the domain of the function. The fact that an odd function test is f of negative x equal to negative f of x implies that f of x is unique for different values of x. Hence, the odd function passes the horizontal line test. Why? Because an odd function implies that the mapping is 1 to 1. So if the mapping is 1 to 1, we cannot find any situation where a single value of y will have more than one value of x for the odd function. It will have exactly one value for the x, for the odd function. So the answer to this question is the odd function. So it goes, odd goes there in the space. Let's take a look at the next question. The next question is as follows. For any function y equal to g of x, the vertical line test, once again, the vertical line test, it shows that the vertical line intercepts a function in exactly one point, same as the horizontal line test. So for any given function y equal to g of x, the vertical line test verifies if g of x is, and we have, for example, even. Okay, a function can be even. If it is even, then we may have, for a single value of y, multiple values of x distributed evenly around or about the y-axis. But if we draw a vertical line, we will not find any place where the vertical line will intercept the function in more than one point, because that will annul the fact that it is a function. The same thing applies for the odd. And this is not even, and this is neither even nor odd. All of them, a function cannot be a function if it maps any of its domain elements to more than one element in the range. And that can only be determined if we did the vertical line test on every value of y of x that is available in the domain. We have to do this test. If we verified that the only intercept is a single point, then it's a function. But if the intercept in more than a point, then it's not a function. So the answer to that is function. We have to plug in function right there. The vertical line test ensures that for every x in the domain, f of x is absolutely unique, and that's why this is function. Let's go ahead and do the rest of the problems. The next question is to sketch a function, and this is not just any function. Sketch the function f of x equal to log to the base 0.5 of x. To sketch a function, we normally build the table and then sketch the function. But building a table for this one is a little bit complicated. So since sketching such function is not easy, let's consider its inverse. Let's take a look at its inverse. How do I get the inverse? The function f of x can be rewritten as y equal to ln to the base 0.5 of x. Therefore, its inverse can be determined by solving the equation that we get by replacing for y x and replacing for x y. So we have to solve for y to get the equation of the inverse. If we do so, we're going to get the inverse something like this: 0.5 to the power x equal to y. So this is the inverse. Let's call the inverse y equal to g of x. And now let's work for g of x. First of all, we can build a table for this one quite easily, because all we have to do is we have to choose different values of x. For ascending values of x, y should be descending. And for that, let's go ahead and take a look at the table for this function. And the table is as follows. We can see this is 0.5. If we raise it to the power -3, it's going to give us 8. We raise it to the power -2, it's going to give us 4, and so on. So this is the table for this function, and this function is the inverse of the function that we want to plot. So all we have to do is we have to just exchange the roles of x and y, and that will give us the table for log to the base 5 of x. So first, let's take a look at the plotting or the sketching of this function. If we sketch this function, we're going to get something like this. Okay, and since this is exponential function, this is exponential function, this one is exponential function, all exponential functions pass or cross the y-axis at the point y equal to 1, and this is crossing at the point y equal to 1. And of course, now we could go ahead and use this table by putting y instead of x and x instead of y, and that will give us the table for the inverse. So log to the base 0.5 of x, its table is right here. It's not easy for us to figure out the log when the base is like 0.5. So we got it in an easy way by looking at its inverse. So if this is the table for this function, then we could just go ahead and look at the graph. This is the graph for the function. This is the one that we're looking forward to sketch, and that will solve our problem in a much better way than trying to figure out this table from this function. That's it for this one. Let's go to the last problem. The last question we have to sketch the function, which is x squared minus 4x plus 5. Sketching this as a polynomial, we're going to have to do a table, and calculating the table is going to be painful. It's complex, it's complicated, there are a lot of intricacies. What we can do is we can just break down this equation, and I'm going to show the breakdown of the equation using the sketches of graphs that we know, and then we will get back to the explanations. So let's go to the graphs. Here is a graph. Everybody knows that this graph is for y equal to x squared, because when x equal to 1, y is equal to 1. When x equal to 2, y is equal to 4. When x is equal to -1, y is equal to +1. When x is equal to -2, y is equal to +4. So this is the sketch of y equal to x squared. Let's take a look at the second sketch. The second sketch is for y equal to x squared, but we went ahead and displaced this one. That means we moved it 2 blocks. So we moved everything 2 blocks. That means the origin is no longer is the least point. This is the point with the least value of y equals 0. So y equals 0 becomes at the point x equal to 2. So this is equivalent to saying this is y equal to x squared, and this is y equal to x minus 2 all square. This one. So this one represents y equal to x minus 2 all square. Let's go ahead and do the second move. The second move is to shift this one up by 1. and if we shift it up by 1, we achieve this equation. This equation is achieved. Let's go ahead and label each and every one of these curves. We know that the label for this one is y equal to x squared. If we want to shift this one to 2 blocks, we have to subtract 2 from x and then square. So this is the function. 2 subtracted from x and we square the result. That will give us this function. And then we can see that this is equivalent to this one, except we have to add 1. If we add 1, that means we want to shift this one up by 1. If we shift this function up by 1, we get this function. And this function is basically f of x equal to x squared minus 2 all squared plus 1, which is equal to this one, which is the sketching of this function. So it's just that we have to, anytime we have any polynomial, we have to see if we can break it down to functions that we know, or at least one function that we know, and then we could go ahead with shifting up, shifting down, stretching the function, shrinking the function until we get our answer. That's it. And thank you for watching, and you have a great day.